Hello everyone. So today we're going over 2.3, getting information from the graph of a function. So first part in this section, we're going to talk about values of a function, the domain and the range. So here is the values of a function, focusing of the domain and range. Domain and range. Okay. So the starting this section by giving like example for this. So the example is example by using the graph. First one, I'm going to graph it. Number one, find f of 1 and f of 2. F of 3 and f of 5. This is number one here. Which number two? I'm going to graph the graph of the function. Number two, which is larger, f of 1 or f or f 5. Number three, find the values of x for which f of x equal 25. And number 4, find the values of x for which f of x greater than 25. And number 5, find the net change from 1 to 3. Net change from 1 to 3. This is the example. Now I'm going to graph the function. So the graphing of this function is look like this. This is my x-axis. This is my y-axis. Okay, the function has from 1 to 5. It is 1, 2, 3, 4, 5, 6. Here's the at 1 is 25, but it's okay. So I'm going to make it 10, 10. So this is 10, first 10, or 5. This time make it like 5, 10, 15, 20, 25, 30, and here is 35. So this is 1, 2, 3, 4, 5, 6, 1, 5, 10, 15, 20, 25, 30, 35. 35. Okay. So the first point here, three, like this, at 4, at 4, at 5, have 6. The graph of this function is, so the function is given, so the function looks like this. The function is given. The graph of the function is something like this. So this is my function. It's something like this. Now, the question is find f of 1. Number 1, find f of 1. Here's number 1. F of 1, you have to find the value for f of 1. Number 1 here, f of 1. You have to see, you have to graph a vertical line, and you see at 1, and you see where is the vertical line. So suppose this is my vertical line. You have to graph like a vertical line like this, and you should to see where is the vertical line intersect the curve at 1. So I'm going to do the first one, f of 1. Here is the one, number 1. So you have to graph a vertical line like this, and you have to see where is the vertical line intersect the curve. As we see here, the vertical line intersect the curve at this point, and this point, they have a y value. The y value of at this point, the y value at this point is shows in the graph is looking like 25. So f of 1 is 25. Who will do the second one? What is the value at f of 3? At 3. What is the value at 3? What is f of 3?
30.
F of 3, you have a vertical line, like Imran said, 30. So you have to make a vertical line at 3, like this. And you have to see where is the intersect of the curve. So as we see here, the curve and the line intersect at this point, and this point it has y value is like 30. So f of 3 is 30. Now what is f of 5?
20.
20. It's doing the same thing. So here is the 5. Intersect the function at this point. This point like it close to be like 20. Yes, this is correct. Is it close to be 20? So here is 20. How did you find this point? Eric, ask me this question. How did you find this point? The question, they give you the graph. They give you the graph like this. The function, the question, they give you the graph of the function like this. And they told you, yes, the graph is given. Exactly, the graph of the function is given with the question. Okay, so the graph with this question is given. That's why. The graph is given with a question. Okay, so the same things you have to find the first question here, find f of 1, you have to graph a vertical line. You see exactly where is the vertical line intersect the curve, and you should to know the y value. Just draw like a horizontal line. You see where is this horizontal line across the y axis, where is it crossing the y axis. So at f of 1 is 25. If you go at 1, the same thing, the vertical line, you see the vertical line intersect the curve at this point, and the y value at this point at the intersect is 25. For the second one, the same idea. You go to the 3 like this, and you see where is the line intersect the curve. As we see here, the curve and the line intersect at this point. So the y value at this point is 30 of the y-axis. So the answer is 30. The same things for f of y. If you have to vertical line, raising a vertical line, you have to see where is the vertical line intersect the y-axis, and the same idea. You have to find, so it's intersect the y-axis at this point as like 20. So the answer is 20. Okay, now for the second question, which is larger, f of 1 or f of 5? Question number 2, which is larger, f of 1 or f of 5? So from the previous one, we get f of 1 is 25 and f of 5 is 20. So who is larger, f of 1 or f of 5? As
F of
we,
1.
yes, f of 1 is larger because f of 1 is 25, but f of 5 is 20. So f of 1 is greater than f of 5. Why? Because f of 1 is 25, but this is 20. So 25 is greater than 20. Is it clear? Okay, for the third one, find the values of x for which f of x is equal 25. What value of x, what values of x, value or values of x, such that the y value is 25?
1 and 4.
Ahmed said 1 and 4. So the best idea to find a question like this, you have to graph a horizontal line like this on the 25. So you see the 25? This is y value. This is my y value. This is my y value. So my y value is 25. You should to draw a horizontal line. And where is this horizontal line intersect the curve? So it shows in the graph intersect the curve at this point and intersect the curve at also this point. This point and this point. At this one point is looking, we look into the x-axis. The value at x-axis is 1, and this point, if you look into the x-axis, it shows 4. The value here is 4, but my graph is not accurate, but here the value, it is 4. So this is my 4 value. This is the 4. So again, at 25, the y-axis is 25. So the x value is 1 here, and the second value is 4, this. So for the third question here, for the third one, number 3, find the value x equal 1 and x equal 4. Question number 4. Find the values of x for which f of x less than 25. Here the question asking about interval. Find the values of x for which f of x is greater than 25. When you see something like that, f of x is greater than 25, the question actually asking about intervals. It's not asking about point like the previous one. So Eric said 2 and 3. 2 and 3. What about 2.5? 2.5 is inside the interval, right? What about 2.6? Eric. Eric said just only 2 and 3.
Can you say
What about
can you say one all the way to 3, all values between 1 to 3?
all values between 1 and 3 and
Yeah,
4, right?
and
And 4,
4. But
yeah,
but 4 and 1, like don't do the equal sign for them. Just do like,
exactly. So it will be like open parentheses.
yeah.
Like I told you, for 3 should be like interval. And for 2, for number 3, I mean here, for question number 3, for this one, this part, find the value at equal. This is just point, x equal. But for number 4, find the values of x for which f of x greater than 25. This is mean you have to graph a vertical line like this, the blue one, and you have to look in where, when this value, when the curve is above of this axis, when the curve, the red curve, is above of this axis, as we see here, at 25, as we look into 25, the curve will be above of this axis, is not in this interval. In this interval, as we see the red here, is below the x-axis, is below the red, the blue line. But here, the curve is above of the blue line. So this is my answer for this question. Now here, the curve goes down, is below the blue line. So this is mean when f of x is greater than 25 in this interval. This interval actually is not 1, but starting from 1. And is not 4, but they ended at 4. So I can make it like Ahmed said, I can make it like open parentheses from 1 to 4, and the 4 is open. And some students said like you can choose any point 2 and 3, only 2 and 3. This is correct. This is not correct actually, is not correct, because also some points like 2.5 or 2.6 or 3.6, all these values here, all these values are inside, are satisfied to be f of x greater than 25. So this is mean the value here, the solution for the number 4 is open parentheses from 1, and the 1 is not included, to number 4, and the 4 is not included too. Again, for question number 4, they ask about interval, and they ask when this f of x is greater than 25. To solve this one, you have to graph a blue line like this at 25, horizontal blue line at 25, and you should to know where is the curve, is above of this line. So the curve will be above in this line as if 1 as you see here and end it at 4. But the 1 and 4 are not including. Why? Because we don't have equal here, equal 25. At 1, the answer is 25 exactly. And at 4, the answer is 25 exactly. But the question is when the function will be greater than, like more than 25, will be more than 25, starting from 1, ended at 4, and the 1 and 4 not included. So the answer is from 1 to 4. Number 5, who will do number 5? Question number 5, the net change. What is the formula for the net change? What's the formula of the net change from 1 to 3? Mayesha said 2, but can you give me the formula? Did you remember the formula?
Yes, Professor.
Yeah, what is the formula?
Uh, if I'm not wrong, the formula was f of b minus f of a.
Exactly, f of b minus f of a. This is my b, this is my b, and this is my a. This is my a. So the formula, the net of change, net or net change equal the f of 3 minus f of 1. So f of 3, you have to graph like the first part, find f of 3. So actually you find the f of 3 from the first question, from the first part. F of 3 here is this. This is my f of 3, this one. And also f of 1, this one. This is the value. We found it already. F of 1 is 25 and f of 3 is 30. So we just subtract the 30 minus 25. 30 minus 25, they give 5. And this is the net change of this function. Any question for this example? Is it clear? Any question for this example? If you have any question, so okay, I'm going to give you like more additional question. For number 4, find the values of x from here for which f of x is greater than or equal 25. How can I do it? I'm going to add the equal here. F of x greater than or equal with the equal sign, 25. What is the answer? Eric said the close interval from 1 to 4. Who said the same answer for Eric? Is Eric has a right answer? Again, find the values of x for which f of x is greater than or equal 25. What is the answer? So the answer without equal is open parentheses from 1 to 4. But what about if we have equal? Yes, this is correct. So the answer will be including the 1 and 4. If we have equal here, greater than or equal, this is mean we have to include the 1 and 4. So the equal, yes, we should to include the 1 and 4. The same things, but including the 1 and 4. This is the answer. Now we're going over the domain and the range from the function, from the graph. So now by using the graph, we can find the domain and the range for any function. So the domain and range, a graph from a graph. So suppose I have a graph like something like this. This is my y-axis, and this is my x-axis, and the curve of the graph, the graph is something like this. This is the graph of my function. Suppose this is my graph of my function. The function has name f of x. This function has x. This is my x-axis. This is my x-axis, and this is my y-axis. So you should to know the domain of the function. If my function look like this, I can obtain the domain and the range from the curve such that the domain of this curve is all value are used for this function, or all values for x, all values of x that which define the function. So as we see here, all values that used for the function and make the function define is starting from this point and also using all these points up to this until here. So as we see here, all these values are used. So this is me and this is my domain for this function. Starting from here, ending at this. This is my x1. This is my x2. Here's my x2. Here's my x1. Okay. So the domain of this function is the blue, this blue interval. This is my domain. The x values, all x values which make the function define. As we see in the graph, all these x values starting from this point, ending at this point, and all values in between are used to make the function define. Now, for the second things, the range of this function, all y values that come from the domain. So after we plug the domain, they give me all this y values. So this is my first point y1, And also this is my y2. And all values that use, this is y2, and all this values was used as the answer or the output after we plug the domain values. By the way, the domain is the input and the range is the output. So the domain is the input set. This is just review, and the range is the output. Any question for the domain and the range? So after now, we can, if by using the graph, if we have the graph of the function, we can know what is the domain and we can know what is the range. Do you have any question for this? So I'm going to give an example if there is no questions. So the example is from the graph, find domain and the range of the graph function. Okay, so I'm going to graph the function here. So this is the graph here. This is my x-axis. And this is my y-axis. And suppose the graph something like this. It's half of circle. My graph is half of circle. This is my function. So this is my function, f of x. F of x. Such that this point here, this point is -2, and this point here is +2, and also here is 2. The question is find the domain and the range. What is the domain of this function? What's the domain of this function? Which x value are used and make the function define during the graph?
Can you see negative? Is the answer going to be an interval?
Yes, the answer will be in like an interval. So what's the interval is the domain.
So from negative, all values from -2 to 2.
Yes, this is correct. As we look into the graph, thank you, Ahmed. So as we look into the graph, starting at -2, this point are used because the value of -2 is 0. The -2, the value is 0 for the function, is 0 as the y value. At this point, the value goes up like around 1 or -half. If you using all this point, you will see all this point, they have a y value. All this point, they still have a y value. up to 2, number 2. And also the 2 is also inside the domain because the value at 2 is 0. The function is 0 because f of 2 here is 0. So the domain is the open close interval because the 2 and the minus 2 is included from minus 2 to 2. Now what is the range? What's the range? What is the y values are used?
Isn't it the same answer?
Same answer from minus 2 to 2.
Yeah.
But as we see here, the minus 2 does, like if we're going to the y-axis, the minus 2 does not have like x value. I mean, like the minus 2 are not used in the y-axis.
The range is 0 and 2.
Yes, starting from 0, as we're looking at 0, this y value is used because f of minus 2 is 0 and also f of 2 is 0. So the y value are used. Also, all this point are used. Why? Because if we going here, f of 1, for example, f of 1, the one has like y value is here, this around here. So I mean, all y values are used here in this graph. It shows starting from the 0 and going up to the 2. The 2 is used because f of 0 is 2. So all this value are used. So this is my range. So the range is the closed interval from 0 to 2. Any question for this example?
Yes, Professor. Can you explain the domain, please?
The
Again.
domain. Okay, so
Thank
for
you.
the domain, again, for the domain, you ask yourself which x values are used for the graph. So the graph of this function is half of circle like this. If we going, for example, to this point, minus 3, we're going to the minus 3, for example, we're going to the minus 3. The minus 3 does not have a y value. So this is not inside the domain. If you go, for example, to the minus 1, minus 2.5, you go to the minus 2.5 here, this point. I mean, like 2.5 at this point. We don't have a y value. This does not have like, does not intersect the curve. But if we're starting from the minus 2 at this point, you will see the value for the y or the f of x, they have a 0 value. If you, for example, go to this point here, you will see this value for x is used because they give a y value. This is my y value here. Also at this point, also the curve used because they graph the curve. They give me a y value. If you come here, you will see also y value. At 0, also you will see y values. At this point, also they have a y value. All these points are used to graph this function. At this point here, 3 does not use to graph the function. I mean, for the domain, if you want to think it more, you will see here all these points are used for x to graph the function. But after this, we stop here, we come to the 3, you will see we don't use the x values to graph the function. So the domain, which value use or which value use to graph the function?
Yes, Professor. Thank you. Got it. One more question. So the range shouldn't be it's minus 2 to 2. Why?
The range will be from the 0 to 2. Why? Also the same idea. You look into the y-axis, you have to ask yourself which y values in the y-axis are used. Same idea exactly. So as we see here, if we come to this point, we will not use it to graph the function. But if we come to this point, the same things. We do not use it to graph the function. See this point, we will not use it. But at 0, we use it because they give me minus 2 and 2. At this point, used. Look, it intersects the curve. At this point, yes, we use it because it intersects the curve. at this point intersect the curve. So the range starting from the 0, because they start intersect the curve, if you use going horizontally, up to 0, up to 2, until the 2. Make sense? Okay, so the domain is from -2 to 2, and the range is from 0 to 2.
Professor, I have a question.
Yes.
So how do you know when it's an open or closed interval? Like for here, for example, it's open, but I mean closed. Would it ever be opened?
In the previous example or in this example?
Okay.
You asked me in the previous example?
No, in this example, like it's
Okay. Okay, I get. Okay. So when you see here, like always, if it's a close a circle, if the endpoints here, for example, if to find the domain is starting from -2 to 2. So that at -2, as we look here at the -2, the value of f of x, like f of -2, as we see to the graph at -2, the value of f of -2 is 0. They give me a value is 0. So at -2 is including. So this is mean you have to make it close. Also at 2, f of 2 is 0. Also we have to make it close because they give me a value. The endpoint, they give me a value. At endpoints, at f of -2, they give me 0, and f2, they give me 0. So both of the endpoints is including of the domain. The range is the same things. At 0, we have two value. F of -2 is 0, so the 0 is used and is including. Also f of 2 is 0, so the 0 is including. So the 0 for the range is including. And also here, the 2 is including because at x equals 0, at x equals 0, f of 0 is 2. F of 0 here is 2 value. So the 2 is used. So we have to make it close.
okay. Thank you.
Any question? Okay, so let's go now. This is about the domain and the range. Now we're going to solve equation and inequality by using the graph. We're going to solve equations by using the graphs. Solving equations and inequality. Graphically. So I'm going to give you like the definition or the idea how we can solving equation and inequality by the graph. So first of all, we have to know this idea. The solution, solving equation means we're looking for solutions. We're looking for what? Solutions. So the solutions of equation f of x equal g of x. So if I have two functions, a graph of two functions, the first function has is named f of x, and so the second graph is g of x. I have two graphs. First graph is f of x, and the second graph is g of x. The solution of equation f of x equal g of x, both of the equation are equal to each other. are the values of x where the graph of f and g intersect. So we're looking where is the intersect between the two functions. We're looking where is the intersect between the first curve and the second curve. Between the first curve is f and the second curve is g. So we graph the first function, f of x. We graph the second function, g of x. We're looking where is the intersect between the two curves to find the solution of these two equations. This is the first idea. Second things, this is for equation. Now for inequality. The solutions same thing. The solutions of inequality f of x is less than here. So this is inequality because we're using less than or greater than or less than or equal or greater than or equal are the values of x where the graph of f, I mean of g is higher than the graph of f. I'm going to explain this. So to find the solutions for inequality f of x equal g of x less than g of x, we look into the both of the graphs in the curve in the Cartesian plane for f of x and g of x. Is the x values, the solution always the x values, whereas the graph of g is higher than the graph of f. It's above of the function. The graph of g is above of the graph of the function f of x. I'm going to do this by example to show you what exactly, how is the graph will be above and where is the intersect between the 2 points to find the solution here. Suppose I have a function, a graph of function look like this. Here is my Cartesian plane. This is the first Cartesian plane. This is my second one. Suppose my graph of the function g, the function g of x here, has a graph look like this. This is my graph of g function. This is my g function, g of x. And also, in the same times, I have another function is my f of x. My f of x look like this. F of x. Now, to find the solution of the equation f of x equal to the g of x, so my question is, find the solution when this equation is equal to this when this function is equal to this function. To find the solution of this function equal to this function is the x value where the f and g intersect. So as we look at here, the intersect point between the both of the function is here. This is the first intersect, and this is my second intersect. So the solution is the x value. The x value mean
in a circular function.
this is my x value. This is my first point, x1. This is my second point, x2. So this is the first intersect, and this is my second intersect. So this is the solution. Here I can write down behind this graph the solution of the function f of x equal g of x are the values x1. I'm going to change it to a comma b. It's better than x1 x2. So this point here is a, and this point is b. So this is my a, and this is my b. So the solution of when the function are equal, both of them are equal, is the intersect a comma b. Now for the second graph, my g of x, same things like this. Here's my g of x, and this is my f of x. Here is g of x, and the blue one is f of x. So the question is, the question is, find the solution when f of x is less than g of x. Find the solution of the inequality g of x is greater than f of x. This is mean we look into the x value where the graph of g is higher than the graph of f. If we look into the both curve, the graph of g, the blue one, the red one, this one, the red one, will be above or higher than the graph of f. So the graph of g will be above of the blue one at this point. Starting from this point and all this point, the graph of the red one is above of the blue one. All this value is above until this point. Then the blue one is, the red one is below the blue one. So, but yes, go ahead.
So for example, if we name the first intersection A and the second intersection B, can you say the parentheses A comma B as an interval?
Yes,
I mean, yeah.
but the A and B are not included because we don't have equal here.
No, interval, to do an interval.
Yes, interval from A to B, but with like open interval.
Yeah, parentheses.
Parentheses, correct. Yes, this is correct, Ahmed. So if we need the solution here, the solution set always for the interval, the solution is the solution always for the inequality is interval, but the solution for equation is always point. So here is the interval. The answer will be as open interval. This is my A. This is B. And the solution for this one is the open interval from A to B. Why? Because the red curve, the red curve here will be above of the blue one. So this is the solution. When g of x is greater than f of x means when the red one is above of the blue one. So the set of the solution of f of x less than g of x is the interval open parentheses a comma b, a comma b, a and b not included because we don't have the equal. Any question for this? Any question? I'm going to give another example. This example by like numbers instead of symbols. Instead of a and b, we're going to use numbers. Okay. So example. Solve the given equation. First one, this is the example question. So number one, x square, number one, x square equal x plus 2. Number two, x square less than x plus 2. Number three, x square greater than x plus 2. Here x square, here x square, here x square. So yesterday, last class, we learned how to graph the x square only. This is a power function. We made a table and we choose random points, and it was like look like a parabola or a cup. We graphed this one in the previous class. It's a parabola. Also this one, x plus 2, it is a linear function. We graph like this one a lot. The slope is 1 positive, and the y-intercept is, what is the y-intercept for this one? X plus 2 is 2. The y-intercept is 2, and the slope is 1 positive. So the graph of the first function, x squared, is a parabola. Let me graph both of the functions. Again, my first function, my f of x is x squared, and my second function is x plus 2. So the first function, x squared, the graph of the x squared, it's a parabola. As we learned from the previous class, we made a table and we pick random points. So the graph of this one is look like this.
I have a question.
Yes, go ahead.
You don't, why do you not subtract x squared on both sides? And then so you get the equal to 0 and make it an equation.
Yeah, but the question is solving this given question by like graphically.
Oh,
by
okay.
the graph. We can do this one, like you said, not by graph, like subtracting, and we solve it like we learned in the previous classes. But today we're going to learn how to do it graphically. Like we show two graphs and we have to look for the intersect, like I said in the previous slide, here graphically. By using the graph. So we need to use this number one, number two, property number one, property number two. And we're using the same things like here, the red one, and like the same this graphs. Ahmed said we can subtract and we solve. This is correct, but this is not graphically. The question is graphically. You should to graph the first function, you should to graph the second function, then we have to solve it. So this is the first function. This function at 0 is 0. 0 is 0. At 1 is 1. So this is my 1. At 2 is 4. This is 2, for example. And they have a 4. Here is the 4. And the same things. Now for the second function is x plus 2. X plus 2, they have a y-intercept at 2. So it's a linear function. The line will be something like this. The line for the second function is like this. Like this. This is the function x plus 2. But the red one is x squared. X squared. Now the intersect, when x squared equal x plus 2, we're looking for the x values such that intersect, such that the both of the curve intersect. By the way, this point here is -1, and this point here is 2. This is 2. And this is -1. Now, first question, who will do the first one? Who will solve number 1? Where is x squared equal x plus 2? Or in the other word, where is the curve x squared intersect the other curve x plus 2? Which x values the both of the curves intersect?
I think they both intersect at -1 and at
And what?
positive, around +2, but a little bit
It's positive
more.
2. It's 2.
Yeah.
Yeah, so this is correct. We're looking for the intersect between the blue one and the red one. So as we see here, the intersect value is at x equal 1 and at x equal 2. So the first question here the value, the answer, x equal 1. This is my -1 and x equal 2. This is the answer. Now number 2. Who will do the number 2? When x squared is less than x plus 2. On the other word, when the curve x plus 2 is above of the x squared. When x plus 2 is above of the other function x squared. When the blue one is above of the red one. In which interval? If we're starting from here, we will see the blue one is down of the red one. Look, the blue is down. It's not above. The blue is down of the red one until this point. Then the blue one here is above of the red one. The blue is above until this point. And after this point, the blue becomes less than the red one. The blue is behind or less than the blue one. Eric said from 2 to infinity. Actually, you have to look for when the blue one is above of the red one.
Is it
So
-1 to 2?
exactly, is if we look up here, is from -1 to 2. The blue curve x plus 2 is above of the curve x squared, the red one. So actually the answer is from -1 to 2, because here the function, the blue one, will be above of or higher than the red one. So yes, Eric, this is correct. So the answer is the open parentheses. Why open parentheses? Because we don't have equal sign here. Here we have just only less than. So open parentheses from -1 to 2. This is the answer. Question number 3. When x squared is greater than x plus 2,
It has two different intervals.
exactly, we have different interval. What's the first interval and what is the second one?
The first one I think is -infinity to -1.
This is correct, from -infinity to -1, and both of them are open union. Okay, this is
Yeah.
mean. And what's the second interval?
2 and infinity. Positive.
Exactly, this is correct. The first one, the question here asks when the red one, when x plus 2, the blue one, the blue curve, is behind or less than down of the red one. The x plus 2 is the blue behind or down of the red one. So the blue one will be down here in this interval. Here is down, then become above, higher than, and the top, higher than, then down. So the down is from -infinity to this value -1, and also from 2 at this point to infinity. This is the solution for the third one. Any question?
So for number 2, you got -1 and 2.
Yes. For number 2 is from -1 to 2. Because the function x plus 2, the line function or the linear function, is above of the parabola function in the interval from -1 to 2. Or you can say the blue line here, the blue curve is above of the red curve at this point, from starting from -1 to 2. A quick question, how did you graph x squared and x plus 2? I just want to make sure. The graph of x squared, we graphed it last time in the previous class when we make a table. And the graph of x plus 2, it's a line. We graphed it also in the previous classes. X plus 2 is a line. The slope here is 1, positive, and the intersect of the intercept is 2. You should to know the graphs of the function x squared and x plus 2. If in the exam I give you a different graphs, you have to make a table. Maybe I can combine 2 questions in 1 question. Like I told you, graph, and then after that you graph, solve the equation graphically. I can combine 2 questions inside 1 question. Like I told you, graph the function x cube plus 1, for example, and graph the second function x plus 2. You have to make a table for both of the functions. After you finish and you graph both of them and you find the table, you make a table. I told you solve the given equation graphically, like this. Okay, so now let's go to the increasing and decreasing function. Same section 2.3. They have a part of this section is talking about increasing and decreasing functions. Increasing and decreasing functions. Okay, I'm going to give you the definition direct, then I'm going to explain, I give example. Definition. The function f is increasing on an interval I if f of x1 less than f of x2. Whenever x1 less than x2 on the interval. This is the first definition, increasing. Now for decreasing, the same thing. F is decreasing on an interval I if f of x1 is greater than f of x2 whenever x1 is less than x2 in the I. Okay, this is I, the interval I. This is I. Here I have f is increasing on an interval I. If f of x1 is greater than f of x2, and here x1 here x1 is than x2. If x1 greater than x2 for x1 less than x2. Okay, let me explain this by graphically. So this is my Cartesian plane, xy. This is my x-axis, this is my y-axis. Okay, suppose my curve look like this here. This is my curve increasing. And this is decreasing in the second one. So in the first function, the function here, this is x-axis. This is y-axis. So the function here is increasing. The reason we say here the function is increasing, the function here is increasing. Why? If we're going to apply this definition, f of x1, first of all, x1 is less than x2. So this is my x1. This point is x1. And this point is x2. So actually x2 is greater than x1, because if we, like, for example, if we have here 1, here we're going to have like 3 or 4 or 5. This point x2 is greater than x1. Now if we're raising the points up to see what's the value for x1, the value of x1 here, this is the value, and also, so this is the value here. So this is my f of x1. This is f of x1. And again, this is my x2, and this is my f of x2. This is f of x2. So actually, if we're going to applying the definition for this one, x2 is greater than x1, and also f of x2 is above of f of x1, so f of x2 is greater than f of x1. So this line, this curve is increasing. So this curve is increasing. Here increasing. Again, x1, x2 is greater than x1, and the value for x1 is f of x1, and the value of x2 is f of x2. The f of x2 is greater than f of x1, so increasing. Now for the second function, the same idea. Here, increasing function. Now for the second function, here is the point, and here is the second point. This is x2, this is x1. Here is f of x2, and also here is f of x1. Again, f of x2, I mean x2 is greater than x1, but f of x2 is less than f of x1. So x2 is greater than x1, as we see here in this graph, and x2, f of x2 is less than f of x1. This is mean the blue curve is decreasing. So here, decreasing function. Any question? Makes sense? Any question for the both of the curve?
Yeah.
Okay.
So
So
shouldn't
yeah, go ahead.
the second definition, shouldn't it be x1 is greater than x2?
For the second definition, because it's decreasing, x2 is greater than x1, right? But the function f, after we plugging inside the function, we're going to see the inverse. I mean, like f of x2 is less than f of x1.
Oh, okay.
Because it's decreasing, the function is decreasing. But for increasing, the same, like the same direction. x2 is greater than x1, and also f of x2 is greater than f of x1. So this is increasing. Decreasing, f of x2 is greater than x1, but f of x1 is less than f of x2. Why? Because the function is decreasing. We're going also, we talk about this inside this function here, the decreasing. x2, if we look into the graph, x2 is greater than x1, but f of x2 is below of f of x1, and so it's less than f of x1. That's why the function here, the blue one, is decreasing. Another way to find the function, to see the function increasing and decreasing, if you're starting from the left and you're going to the right, as you're seeing the point, you see the red one is going up and up. If you're looking from the left, starting from the left side to the right side, you see the function here, the function goes up and up. And also, if you look into this side from the left side to the right side, you will see this function goes down and down like this. So this is mean decreasing. Here it means increasing. Okay, I'm going to graph it again. So again, to see the function, if it's the function increasing or decreasing without applying the formula or the definition, here, if we're starting from the left, like I mean, starting from points in the left to the right, like this, all the points or the curve goes up like this. Look, the curve is going up. But for this one, if you starting from the left to the right like this, all the points goes down. Look at the points. It's become less and this, like this. So this is mean is decreasing function. Okay, so I'm going to give example. Suppose I have the curve like this. This is my curve. So here is the question example. Find the increasing and decreasing
She just did.
interval. Intervals. Okay, so the function look like this. Starting at this point, then moving like this. This point here is A. This point here is B. This point here C. And this point here is D. The question is, where is the interval for increasing and where is the interval for decreasing of this function? This function has a name f of x. When f of x is increasing and where is f of x is decreasing?
F of x is decreasing at C and A
From C,
to A.
do we, from C to A like this, right? From A to
Yeah.
C.
It rises at B, but it goes right back down at A.
C to A, this point from here, but here as we see the functions goes up, right?
Yeah, it rises at
And
B.
here, always when we start looking, the function is decreasing or increasing, starting like this, like I told you, from right to left. So if we're starting from this point here at A, then goes to up to this point, then goes to down, 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 down until this point, then the function goes up until this point, then goes down. What does that mean? Where is the increasing and decreasing? Like starting from the left point,
Isn't it
I mean,
increasing from A to B?
from
And
A
the
to B,
decreases from
increasing.
B to C?
Exactly. Here, I don't need the arrows, so I'm going to close it here without the arrows. Exactly. So as we see here, the function is goes up, 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 up like this, is increasing. Then at this stop increasing, goes down, decreasing like this. Then stop again. Then the function again increasing again like this. Look, it goes up, increase one more time, then stop here. I'm going here to stop and make the function stop. So here is the start point. This is my end point. I mean, this is my end point. Here, I don't need this. This is my end point. So as we see here in this function, the function increasing until this point, decreasing until this point, increasing again at this point. So the interval of increasing, as we see here, the increasing interval is from A to B, but open, always open, A comma B. And also it's increasing again from C to D, as we see here. So comma, C comma D. This is the two interval for increasing. Now, what's the decreasing interval? What is the decreasing interval? Where is the decreasing interval? B to C. B to C. This is correct. You'll get from B to C, but open parentheses, always open parentheses. B comma C. We have only one interval for decreasing. Any question? Any questions for this example? It makes sense? So now by using the graph, you can define where is the function increasing and where is the function decreasing.
So the function is decreasing at B to C, and it increases at A to B and C to D.
Yes, exactly. From A to B and from C to D increasing, because as we starting from the left to the right, we see here the function goes to the mountain up, goes up, up, up until this point, then goes down until the C point, then goes up again until this point. So the increasing interval from A to B and from C to D, and decreasing from B to C. The last things for this section is the local maximum and minimum values of a function.
You forgot.
So the local, yes, go ahead. What's your
No.
question?
Never mind, it's fine.
Okay. For the local maximum and minimum values of a function is not hard, is depending on the increasing and decreasing function. So the point here in the top, when the function changing from increasing to decreasing, at this point B, at x equal B, this point is called local maximum. When the function changing from decreasing to increasing, is this point here in the down is called local minimum. Oh, okay. Thank you. So again, the local increase, the local maximum and local minimum. The local maximum is a point where is the function changing from increasing to decreasing. So the function changing from increasing to decreasing at this point, it's in the top of the mountain. This point is x equal b. X equal b is the local maximum of the function because it's become in the top. Now, when the function changing from decreasing to increasing, this point, it's in the bottom of the mountain. This point is called local minimum. Local minimum. So I'm going to graph a function here, and I will show you the local maximum and minimum. So suppose my Cartesian plane like this, and the function here is look like this, is going up, then goes down, then goes up, then goes down like this, and that's it. So at this point, we need it. Suppose the value here, suppose here, this value is A. Suppose this value here is B. Suppose this value here is C. And also, that's it. So you're supposed to know this point here is called local maximum. Local maximum point. Local maximum point. At this point here, this is local minimum point. Again, at this point in the top here is also local maximum. So we have two local maximum. This first, this second, we have local minimum is here. So I can say here the function f of x, I'm going to name it f of x, has local maximum point at x equal a and at x equal c. This is the first 2 points. We have 2 points, maximum and minimum. Also, the function has the function f of x has local minimum point at x equal b. This is my second thing. I have two things. The function f of x has local maximum point at x equal a and x equals c, also local minimum at x equal b. Any question? Any question for this? Okay, we're going to stop up to here today. Have a good day. See you next week.
Have a good day.